Hello everyone. In this lecture we will be going over 1984 AIME problem number 6. Here's a view of this problem. 3 circles, each with radius 3, are drawn such that their centers are located in these 3 points on the coordinate plane. A line passing through the center of this circle is such that the total area of the parts of these 3 circles to one side of the line is equal to the total area of the parts to the of the 3 circles to the other side of it. Wow, that's pretty long, but I guess you guys understand the meaning. What's the absolute value of the slope of this line which splits these 3 circles into 2 equal areas? So what I have in mind is, let's first start by drawing the 3 circles. So what I will do is I will have probably one circle right here. Now I'll have another one here, and I know they have the same radii, and then that's the last one, so probably like this. Okay, good. So we have our 3 circles. So there you go. Okay, so what I know is that the centers of these 3 circles are 1776. So that's the first one, and I think this one is called as B. This one is the center C, which has coordinates 19 and 84, and finally this one is A, and A has coordinates 14 and 92. So the line that splits these will go through point B, and it will be such that it will split these. That won't do the trick apparently. Yeah, as you can see, my circle, my drawing is not nice, so let me redraw the thing. So let's just, I see, so I need to use another tool here, so let's delete that. Delete. Okay, good. Oh, actually I didn't have to delete. So what I can do is I can just move that circle, isn't it, so that it will benefit my purpose. There you go. I think that does the trick. Yeah, because the line will split the, okay, so that was the tricky. Okay, so let's put back the center here. So the center is probably here. We decided to call it C, which is 19 and 84. Okay, so the trick in this question is that because the line goes through the center B here, the location of this circle is irrelevant, the second circle here. So all that matters is, let me draw the line, so that I need to make sure that it will kind of split these 2 circles into equal, yeah, let's just leave this one here, and I'll just simply move the circle right here, so that it looks, yeah, I think it looks nice now. So here is the trick. As I said earlier, we know for sure that this line will, the red line will be a diameter for circle B. So as a result, all we need to add, it will naturally split them into 2 pieces. So this piece will have equal area with this piece. So therefore, all I need is to add this area here and this area here, and ensure that it is equal to this area on the left side and this area here. So therefore, the sum of the 3 yellow ones is equal to the sum of the 3 green ones. But we already know, as I said earlier, we already know that this and this are equal, so we can just, so it's irrelevant for our problem. All we care is the green here and here, the sum of the green on circle A and C being equal to the sum of the yellow on circle A and C. Now let's think. The way it should be done is that because this green section is equal to this yellow section up here, it means these lengths are equal, and it also means that the distance from the center to the line for both of these circles are actually equal. So I don't know, Let's call this point as E, and I'll use the letter F for this one. So that's good. Moreover, so first of all, so everyone agrees that I assume, so this distance here, FC, is equal to AE. Let me make note of that. So FC is equal to AE, and for a very good reason, because if these two areas are equal, it might be that these lengths here, the chords have equal length. But if two chords are equal length for two circles with the same radius, it must be that this distance is the same as well from the center C to F. And well, the proof is obvious, because half chord here, and then you have the same radius 3. You can apply Pythagorean to find that distance, and it's the same thing, half chord here, which is the same half as here, and then the radius is the same, so therefore AE is equal to FC. So this one is for sure. But second of all, what I know then is that there is a nice similarity going on here. So what I will do is, let's draw this nice, let's connect line points A and C. So I'm drawing line AC, and I claim that the midpoint of this line must lie on the red line, which splits these shapes into two equal areas. So this midpoint, let me call it as M. It's very easy to calculate. The coordinates of that point will be just 14 plus 19 over 2, which is 16.5. And the y would be 92 plus 84 over 2, which is probably 88, 89, I guess. 80, 88. Sorry, it should be 88. And as I said, because of this nice symmetry between the shapes, we know that so let me write that down. So triangle AEM is actually congruent to triangle CFM here. So please convince yourself to see why that must be the case, which is, as I said, obvious. So you have equal angles here, so you have vertical angles. These distances are equal, so there is no option, and these two, so EM is equal to MF, and those two triangles are definitely congruent, and therefore the midpoint of AC is, so let me write that down as well, AM is equal to MC. But then we are done, because we now know the equation of our line. Our line goes through, so let's call that red line as L. So line L goes through, oops, how do you spell through? Shoot. Okay, so let's try again. Okay, let's just write the shorthand. So line L goes through B and M. And now it's obvious to find the slope. All I will do is, so the slope will be equal to ym minus yb over xm minus xb. So ym is just 88 minus yb is 76 divided by xb is 16.5 minus xb is 17. So you would get, I think it would be a negative number, obviously. So this is half, so which is multiplying it by minus 2. So minus 2 times 12, which is 24. So therefore, the answer to this problem is 0, 2, 4, and we are done.